my video that I'm putting together on how to calculate the z-score for a set of data. The z-score is just a representation of the data on the bell curve. A data point with a 2 sigma standard deviation is also equal to a z-score of 2, and same for a 3 sigma standard deviation would be equal to a z-score of 3. I have some more videos breaking down what the actual bell curve is and how to read it, but we're just looking to calculate the z-score from this video. On the right side of the screen, you'll see the actual formula for the z-score. We have our output, which is the z-score. This is the single point of data that we're analyzing, for example, a score of an 89 on a test. This is the mean of all the data, or the average. And then this is the standard deviation of the data. I'll have another video on calculating standard deviation. There's most likely a way to calculate standard deviation in your software that you're using, or there's also a super easy way to do it in Excel. For reference, this is the formula for standard deviation here. I'm not going to go over that in today's video, but this is the formula that you can use in Excel. An important thing to note is that a z-score of 0 means that is the exact average of the group of data. So 0 would be directly in the middle of our bell curve. The first example is a student scores an 85 on a test. The class average is a 75 with a standard deviation of 5. The first thing I'll do is write down our z-score formula, which is z equals x minus mu over sigma. Remember that x is the point that we're analyzing, mu is the average of the data, and sigma is our standard deviation. The question is also asking, what is the percentile rank? In order to get the percentile rank, we first have to calculate the z-score, and then from the z-score we can calculate the percentile rank. And this is to say that the student scored better than 95% of the class, for example. I'll also identify that x is equal to 85, mu, our average, is 75, and the standard deviation is 5. So to calculate the z-score, it's pretty simple. All we do is plug and chug. I'll rewrite our equation. And then x is 85, mu is 75, and sigma, our standard deviation, is 5. That gives us 10 over 5, which means our z-score equals 2. Now we know our z-score is equal to 2, but we need to figure out the percentile rank. To do this, I put together this z-score data sheet that gives us the percentile rank. This column here and this row on the top are the z-scores, and then everything in the middle here is what's known as the probability rank. So we know our z-score is equal to 2.00, and the way this works is we first go down the left side and we look for the 2, and that's the first part of our z-score, and then the second part of our z-score with the 2 decimals is where we track across the top. You can see 0.00 is in our first column here, and if we head down to where these two meet up, we get a percentile rank of 97.72%. I'll include this spreadsheet in the description so you can reference it with me. So that means if we head back to our problem here, we determined that a z-score of 2 gave us a 97.72% percentile rank, which means that the student is better than 97% of the class. Let's try another example. So we know that an adult male is 76 inches tall when the average height is 69 inches and a standard deviation of 3 inches. If he's 76 inches tall, this means that x equals 76, the average, mu, is 69, and the standard deviation is 3. Plug that into our equation of z equals x minus mu over our standard deviation, and that gives us 76 minus 69 over 3, which comes out to about 2.33. Alright, I'm back at our z-score table. We know our z-score is equal to 2.33. And remember, like I said, the first column of this contains the first 2 digits of our z-score, in this case 2.3. So we go down to 2.3, and then the last digit of the z-score is 0.03, which is this box across the top. And when we track them down in the table, we can see that our percentile is equal to 0.9901, which is 99.01%. All right, and that answers this question. We know that a z-score of 2.33 gives us a percentile of 99.01%, which means that he is taller than 99.01% of the population. All right, this last one is a little bit more tricky, but still not too bad. A student scored a 1300 on the SAT with an average of 1050 and a standard deviation of 100. They also scored a 27 on the ACT with an average of 21 and a standard deviation of 3. Based off what we just did, I suggest that you stop here and go try it for yourself and then compare it with my answers when you come back. Let's start with the z-score for the SAT. We know that x equals 1300 because that's the score that they scored. The average was 1050 and the standard deviation is 100. On the ACT, the score was 27 with an average of 21 and a standard deviation of 3. Plug that into our z-score, 1050 over 100, and the z-score for the SAT comes out to 2.5. The z-score for the ACT is 27 minus our average of 21 over a standard deviation of 3, and that comes out to 2. Now we can already tell by looking at this that since the ACT has a lower z-score than the SAT, that the student did better on the SAT relative to their peers. However, I'll still go through the exercise and look through the z-score table so we can get our percentiles. So we said the SAT z-score was 2.5 and the ACT z-score was 2.00. Let's first do the SAT. We have a 2.50, so we're going to go down this first column and down to the 2.5, and the last digit of our z-score is 0, which gives us the 0 column. And if we track down the 0 column to our percentile, we get 0.9938, which is 99.38%. For the ACT z-score, we go down to 2, and the last two digits are 0, which means we're still in the 0 column, and head down to the 0.9772 percentile, which is 97.72. This means that on the SAT, the student was on the 99.38th percentile, and for the ACT, the student was on the 97.72nd percentile. This means that the student performed in the top 99.38% of the SAT, and relatively better than compared to the SAT. Calculating the z-score and the percentile from that table I just showed are both very important for the rest of the statistics. So I hope a video like this is a good starting point to developing further knowledge with the z-score.